So now you've got an inscribed right triangle specifically. So we know that angle B has got to be 90 degrees. And if you notice, angle B is creating that inscribed angle. They all are. And it's telling you that you've got a diameter as that line right there. Notice that is a diameter. That red line's a diameter. And if you remember, half of that circle should be 180 degrees. So this arc made by the diameter is 180 degrees. Does that line up with our rule that if you have an arc and you go to inscribed angle, you cut it in half? Yes, it does. If you double 90, you get 180, or if you cut 180 in half, you get 90. So anytime you have a right triangle inscribed in the circle, a right triangle is inscribed if and only if the hypotenuse is the diameter. So hopefully that's making a little bit of sense. And again, remember that arcs AB and BC would also have to add up to 180. Right now, we don't have enough information to actually figure that out. We would need to know another given situation. Now, a quadrilateral, okay, so now we've got four sides, 1, 2, 3, 4 sides in the picture. They're probably all different sizes, it looks like. So a quadrilateral is inscribed in the circle if and only if the opposite angles are, what do we think? I don't know. Let's figure it out. So if we've got opposite angles, we've got, so like F and D would be opposite angles. So can we figure it out from here? I don't know if we can quickly figure this out without me just telling you. So the arc created there looks like it's close to 180, maybe a little bit bigger. And the arc created there so if I've got the blue arc, E to G, and I've got the red arc right there, okay? Hopefully you're seeing that blue plus the red arc is equal to 360. It's the whole thing. So that E to G plus G to E is equal to 360. Okay. But the interesting thing is about the opposite angles. So we can say that the opposite arcs are adding up to 360. But then what do we know if this is if this angle down here, this blue angle is half of that arc, and we know that the red angle is half of the red arc, then hopefully we should see that angle D plus angle F at the top there. If those are both cut in half, if I divide by 2, I would have to divide this by 2. So those opposite angles have to add up to 180. That S word again is supplementary. Okay, so anytime you have opposite or a quadrilateral inscribed in there, the opposite angles, those have to make 180 and their arcs make 360 together. And again, it's that doubling technique coming into play right there. So again, that came from cutting all those parts right there in half. Whatever you do to one side, as long as you do it to another, it's fair game in a equation. So looking here, I think that probably the right one feels a little bit more. It doesn't actually matter. So as we look at this, we've got a diameter here. We'll start on the left because it's going through the center. And if you remember the if and only if statement at the top, if the triangle, if that line is going through the center, I can automatically call that my hypotenuse. Okay. So if that's my hypotenuse, then this outside arc has to be 180 degrees. Okay. If that's 180, if the measure of AB is 180 degrees, then that angle C has to equal 90. It's got to be half of it. Again, common mistake is people want to say that they're equal, but that's only true for the central angles. This central angle there would be 180 degrees, half the circle. So we know that angle C is 90 degrees. So if angle C is also known as 2x, we can plug that into our equation, and dividing by 2 on both sides, we can get that x is 45 degrees. Remember, the whole angle itself is 90, but specifically x is 45 degrees. Now, if we look at the quadrilateral here, if we've got, just to give us a visual here, we've got this blue arc and the red arc. If I'm picking these opposite angles, the blue arc and the red arc add up to the whole circle 360. But those inscribed angles are half, so y plus 120 has to equal 180. And that was from the theorem right up there. Okay. Moving 120 to the other side, that gives me y equals 60 degrees. So I can go ahead and put 60 degrees down there. And now you have a lot of options. We know that the 3 angles have to add up to 180. 360. The 4 angles have to add up to 360. So you could subtract off 60, 80, and 120. Or you could use the same theorem saying that z plus 80 has to equal 180, forcing z to be 100 degrees. Again, that's me using this technique from the previous question. If you needed to check your work, you can make sure that all 4 angles add up to 360 degrees, which they do.